Here I am with another topic on increasing and decreasing functions. Now, increasing and decreasing function is of chapter 6, application of derivatives. It's a part of application of derivatives. It's a very important topic and there is almost a sure question on increasing and decreasing functions. There's a lot of theory on this particular topic. So here's what is an increasing function. What you have generally heard, increasing यानी जो ऊपर जा रहा है, that is an increasing function. Decreasing जो नीचे आ रहा है. Yes, it is literally by that particular definition itself. If we see now I'll explain you the definition. If y is equal to fx is any function and if x1 is less than or equals to x2, then f of x1 is less than or equals to f of x2, then f is an increasing function. But if x1 is less than x2 and f of x1 is less than f of x2, then f is a strictly increasing function. It is what? A strict inequality. It is not less than equal to, it is only less than. It has to be strictly less than. So that is called a strictly increasing function. If you see the graph for this particular function, if I have a point x1, okay, then the value of the function is what? F of x1, and if I move further, if I am at a point x2, the value of the function is f of x2, which is more than f of x1. So it is what? An increasing function. For example, अगर x1 2 है और f of 2 suppose कोई value 5 ले रहा है और x2 4 है और f of x2 कोई value 8 ले रहा है, तो क्या हो रहा है? It is increasing, so it is going upwards. So this is called an increasing function. Clear or not? Same ways, let us go to decreasing function. If x1 is less than or equals to x2, but f of x1 is greater than or equals to f of x2, then f is a decreasing function. Same ways, if x1 is less than x2, but f of x1 is greater than f of x2, then f is a strictly decreasing function. It is what? A strict inequality over there. For example, if you see the graph, say x1 is some point 2 and f of x1 is some 8 and x2 is some point 4 and f of x2 is some value 3. So what is happening? It is coming down. पहले 8 वैल्यू ले रहा है फिर 3 ले रहा है, तो ऊपर से क्या हो रहा है? नीचे आ रहा है. तो ऐसे फंक्शन को हम क्या बोलते हैं? Decreasing function. So it is coming downward. तो ऊपर से नीचे आ रहा है, तो that is called a decreasing function. But these two definitions we generally don't use. We are doing what? Application of derivatives. So we have to do it by differentiation. So let's see by differentiation how we do it. Fx is given to me. Find f dash of x. If it is greater than 0, then f is strictly increasing. If f dash of x is greater than equal to 0, the strict inequality goes. It can be equal also. Then it is called only an increasing function. Same ways, if you have any fx, find f dash of x. If f dash of x is less than 0, then f is a strictly decreasing function. And if f dash of x is less than or equal to 0, then f is a decreasing function. For a, let's take up a question. 6.2 ka first question is what I am taking up. fx, suppose मेरे को 3x plus 17 दिया हुआ है. You supposed to prove that it is strictly increasing or not. So I find out f dash of x. How much is f dash of x that I get? 3, which is greater than 0. So f dash x is greater than 0. 3 is always greater than 0. F dash x is greater than 0. So f is strictly increasing or not? It would always be greater than 0, so that is why it is strictly increasing on R, on the set of real numbers. Suppose now I take up question 3. Now what is given to me? There is a function fx given to me. I'll read out the question. Show that the function given by fx equals to sin x is strictly increasing on R in 0 to pi by 2. That's the A option. B option, it is strictly decreasing on open interval pi by 2 to pi and neither increasing nor decreasing in open interval 0 to pi. So fx is given to me. I'll find out f dash of x. So what is f dash of x that I get from here? Cos x Now cos x is greater than 0 in 0 to pi by 2. That is the first quadrant. 0 to pi by 2 is what? First quadrant. So as cos x is positive in first quadrant. So f dash x is greater than 0 in open interval 0 to pi by 2. Hence f is strictly increasing. So what happens? F is strictly increasing. Here if it was closed interval 0 to pi by 2, then f dash x would be greater than equal to 0, because cos pi by 2 is 0. Then it would become only increasing. So it depends upon the question what is asked. In some textbooks it is also closed interval. So if it is closed interval, it would be only increasing, as f dash of x would be greater than or equal to 0. But as it is open interval, so f dash x is only greater than 0. Let's see the B part. Now what's the B part? Strictly decreasing in open interval pi by 2 to pi. Now fx is sin x. I find f dash x. What do I get? Cos x, which is less than 0 in pi by 2 to pi. Why? Because that's the second quadrant. So second quadrant cos is negative. It is less than 0. So f dash x is less than 0. Hence it is strictly decreasing. Again it is open interval. That is why it is strictly decreasing. Now the third part. It is neither increasing nor decreasing in 0 to pi. Now 0 to pi is what? Together a combination of the first quadrant and the second quadrant. So what happens over here? Sin x was increasing in 0 to pi by 2 and decreasing in pi by 2 to pi. So together what can I say? That it is neither increasing nor decreasing in 0 to pi. So this was the basic on increasing and decreasing function. We are left with forming intervals. There's lots more to it. This is only the basic of increasing and decreasing functions. So there would be a homework coming on it. Please go through it. And those who have not yet subscribed my channel, please do subscribe my channel. And remember to like us on Facebook and Instagram. Please do.